So reading this, it says the converse of theorem 4.8 is not generally true. That is, it is possible for the second derivative to be 0 at a point that is not a point of inflection. So just because your second derivative is equal to 0 at that point does not mean that it is a point of inflection. It says, for instance, the graph of f of x equals x to the fourth, which is shown in figure 4.29, the derivative is equal to 0 when x equals 0. So think about the slope of the tangent line at 0. Here's that point 0. There's that tangent line that I just drew in red. Notice that f prime of x, the slope of the line, is equal to 0 at that point 0, 0. Okay? It says, but the point is not a point of inflection of the graph of f is concave up on the intervals negative infinity to 0 and 0 to infinity. So if you notice, it's part of a cup this entire time, right? So it's concave up this entire time and it's concave up this entire time. So it doesn't change concavity there. Well, if you notice, f double prime of x is also equal to 0 at that point. So it's saying just because your second derivative is equal to 0, it does not mean that you have a point of inflection. So here's what it would have looked like if we did the number line. We would have had the point 0, right? We would have looked at f double prime of x, and what we would have had was positive 0, positive in this case. Concave up, 0, concave up. So here we would have had a point where the second derivative is equal to 0, but it does not change concavity at that point, so it is not an inflection point. Okay, that's all they're trying to emphasize with that. All right, let's move on to the last cool topic, which is called the second derivative test. This is absolutely going to be on your test. It is on your test by name, so if you do not follow this exact process by name when it says using the second derivative test, then you will receive no credit. So let me read this. It says, in addition to testing for concavity, the second derivative can be used to perform a simple test for relative maxima or minima. So look, again, the second derivative test, very important, can be used to perform a simple test for maxes and mins. So what we just saw was the second derivative is used for concavity. It's used for concavity and inflection points. But what this is saying now is the second derivative test can also be used, or the second derivative can also be used for determining relative maxes and mins, which is what we knew the first derivative did. So it's kind of cool. We could also use the second derivative to do this as well. So it says the test is based on the fact that if the graph of a function f is concave up on an open interval containing c, and f prime of c equals 0, in other words, the derivative was equal to 0, this is a critical value. So if you have a critical value at a point and you're concave up at that point is a minimum. Likewise, if you have a point and you're concave down, that is a critical value, and you're concave down at that point, then that point must be a maximum. Okay? Really cool. So what are you going to do? How are we going to do the second derivative test? The first thing you're going to do is find f prime of x in the CVs. So that's where your derivative is equal to 0 or undefined. The second thing you're going to do is find the second derivative, and then you're going to plug in the CVs into that second derivative. Step 4 is you make your conclusions. If f double prime of x is positive, that tells you that your function is concave up, which tells you that point is a minimum. If f double prime of x at that critical value is negative, that tells you that it's concave down, which tells you that point is a maximum. So there's your second derivative test. The second derivative test gives you the exact same thing as the first derivative test. The second derivative test gives you maxes and mins. It just does it differently. What is the advantage of the second derivative test? Well, for the first derivative test, You need to find the critical values, which you do here, so that's no different. But then you need to draw the number line, determine the intervals, and test points in each one of the intervals, and then look at it and decide, okay, is my first derivative going from positive to negative, would make it a maximum. If my first derivative is going from negative to positive, it would make it a minimum. So you're testing all these different points, one in each one of the intervals. What's the advantage of the second derivative test? You never need to test points in any intervals. All you have to do is find the critical values, which you've already done for the first derivative test, right? But then you find the second derivative, and the only numbers you have to plug in are the actual critical values. You don't need to plug in test points in the intervals. You plug the critical values from step 1 into the second derivative. And if that second derivative at that critical value is positive, it is a min. If the second derivative at that value is negative, it is a max. And if it's 0, the second derivative test is inconclusive. So you still have to do some work. So no more test points, no more intervals that you have to do. You can always use the second derivative to determine maxes and mins. So when would you use the second derivative test? Well, if the problem says find intervals of increasing and decreasing, you've already done the work for the first derivative test, so you might as well use the first derivative test. But if the problem only says find maxes and mins, then the second derivative test can be very useful. I only use the second derivative test when the second derivative is easy to find. So for instance, if you look at our previous example, it was a simple polynomial function. Finding the second derivative was very simple. And if finding the second derivative is easy, then I'm going to use the second derivative test. If finding the second derivative is difficult, for instance, if you have a rational function, a bad product rule, a bad chain rule, a bad quotient rule, then nix the second derivative. You've already found the first derivative, just test a point in each one of the intervals. So if the second derivative is easy to find, I use the second derivative test. If the second derivative is difficult to find, I use the first derivative test. So I hope that helps you out of when to use it and how to use it.